Hi students and friends, welcome to the channel Learn and Teach by Sir AYAZ. This is your host and teacher Syed Ayazuddin Haider. So I'm solving the paper for 9701, that is A levels chemistry. This time I've selected paper 22. It's of February-March 2023. The total time for this paper is 1 hour 15 minutes. You have to answer all the questions. Total marks for this paper is 60. These are some resources which are provided in this paper, that is important values, constants and standards, as well as the periodic table of elements. So let's continue with the paper. Here's question number 1. The following electronegativity values of elements can be used to predict the chemical properties of compounds. Use the information in table 1.1 to answer the following questions. Here's table 1.1. Element provided is hydrogen, lithium, carbon, oxygen, sulfur. Pauling electronegativity value, first ionization energy and second ionization energy in kilojoule per mole is provided here. Part A, number 1, define electronegativity. You know it's the power of an atom to attract electrons to itself. So you write power of an atom to attract electrons to itself. Remember, they are attracting electron toward itself. And those elements which have this power, they are known as electronegative elements. Non-metals are more electronegative when comparing with metals. Number 2, O and S are in group 16. Explain the difference in the Pauling electronegativity values of O and S. See the O and S, where is O? Here is O, group 16, here is S, this is group 16. If you see the Pauling electronegativity value, oxygen have 3.5 and sulfur have 2.6, which is lower than of oxygen, which means oxygen is more electronegative than sulfur. Now, if you look at the position of oxygen and sulfur, oxygen is in the second period. These are the periods. Periods first, second, third, fourth, fifth. Oxygen is in second period. Sulfur is in third period. So oxygen must be having fewer shells as compared to sulfur, which means there will be less shielding of incoming electron or outer electrons. Oxygen also have lower nuclear charge than sulfur. That's why it has greater attraction for the incoming electrons by the nucleus. The main reason is there it has fewer shell and there will be less shielding of outer electrons. So what we will write here, oxygen have fewer shell than sulfur, which means there will be less shielding of outer electrons. Oxygen also have lower nuclear charge. and greater attraction for the incoming electrons. Next question, B. Part 1, LiH is an ionic compound. Draw a dot and cross diagram of LiH, include all electrons. Here is Li. It's in group 1, which means it has 1 valence electrons. Here is hydrogen. It has 1 electrons. Both have 1 electrons. Hydrogen is a non-metal, lithium is a metal, so it must be forming ionic compound. They have already mentioned here. And they are asking you to draw dot and cross diagram. So first of all, we're going to show the key for lithium. I'm using dot for lithium. For hydrogen, I'm using cross. So lithium has 3 electrons. So it will lose 1 electron. It's a metal. It will lose 1 electron. Lithium, metal, lose 1 electron. Hydrogen, it's a non-metal, gain 1 electron. So I'm going to show only first shell of lithium. It's in the second period, so it will lose its valence electron from the second shell. So it will be left with only 2 electrons. So this will be the dot and cross diagram for lithium. I'm showing the inner electrons, 1, 2. For hydrogen, it will gain 1 electron. It's the electron of hydrogen. These are the electrons. This is the electron coming from lithium. So this will be the final dot and cross diagram. Number 2 suggests the shape of a molecule of H2S. Shape of molecule of H2S. We have 1 sulfur and 2 hydrogen. As there will be, look at the position of sulfur. It's in group 16, which means it has 6 valence electrons. So needing 2 electrons to complete its valence shell. So if I will show the electrons for sulfur, it will be like this. I'm using dot for sulfur. 1, 2, 3, 4, 5, 6. What about hydrogen? These are the electrons for hydrogen. So there will be more repulsion between lone pair and bond pair electrons as compared to lone pair. These are the lone pairs. These two are lone pairs. These are the bonding pair of electrons. So definitely it will have bent shape, bent or non-linear due to this. Moving to next part, C1. Write an equation that represents the first ionization energy of H. We know that the ionization energy is the amount of energy required to remove electron from the valence shell in the gaseous state of an atom. So I will write H gas. Only 1 atom, not molecule. So it must be forming plus ion, and it's also in the gas state, and 1 electron will be removed. It will be represented like this. Number 2, explain why there is no information given in table 1.1 for the second ionization energy of H. Definitely hydrogen has only 1 electron, so you can write H positive has no electron. Number 3, give the full electronic configuration of S2 plus gas. S2 plus gas means it has lost 2 electrons. Here's sulfur, proton number 16. Proton number 16, which means electronic configuration will be like this: 1s2, 2s2, 2p6, 3s2, 3p4. Now, after losing 2 electrons, it will be left with 2 electrons in the p suborbital. So I will write for s plus 2, I will write here 1s2, 2s2, 2p6, 3s2, 3p2. D. CO2 and SO2 are acidic gases. Number 1, write an equation for the reaction of SO2 with H2O. SO2 is an acidic oxide, so it will form an acidic solution with water. It will be forming sulfurous acid. So sulfurous acid, the formula of sulfurous acid is H2SO3. Number 2, write an equation for the reaction of SO2 with NaOH. NaOH is an alkali. Alkali is a base. Base when reacts with acid. Here is an acidic oxide. It's either reacting with acidic oxide or acid. It forms a salt. So we are having alkali metal hydroxide. So definitely the other product must be water. So first of all, we need to predict the formula between the sodium and the negative ion here. So we have SO2. So it becomes SO3. SO3 will be carrying -2 charge. Sodium is in group 1, will be carrying +1 charge. Ignore the charges. These numbers will become exchanged. So we'll get Na2SO3. Na2SO3 will be one of the product. Na2SO3 plus other product is water, as I have already mentioned. The full equation must be SO2 plus NaOH gives Na2SO3 plus H2O. Let's balance the equation. I will put 2 here. It's balanced. Number 3, write, construct an equation for the reaction of CO2 with magnesium hydroxide. Carbon dioxide is a gas. When it's reacted with magnesium hydroxide, it will form a carbonate plus water. So we'll get the carbonate of magnesium. The formula for the carbonate of magnesium and carbonate. Carbonate carries -2 charge, and magnesium, where is in magnesium? Magnesium is here. It's in group 2. Group 2 carries +2 charge. So +2, same numbers, ignoring the charges. 1, 1. The subscript will be exchanged. So the final formula must be MgCO3 plus H2O. Moving to next question. E1. Complete table 1.2 by placing a tick to show which of the compounds have molecules with an overall dipole moment. So CO2, SO2, CS2, SCO. SCO must be having dipole. That's for confirm. It must be having dipole if you look at the position of these. Look at the electronegativity value. SCO. So oxygen must be the most electronegative, so there must be dipole. What about CO2? CO2 dipole must be cancelling out. There won't be any dipole here. What about SO2 and CS2? CS2. SO2 and CS2. CS2 is there's a less difference between the electronegativity value of carbon and sulfur, very less. So there isn't any dipole movement here. What about SO2? Look at the difference between SO2, that's 3.5 and 2.6. There must be dipole. The reason is that sulfur is a large, it's in the third period as compared to oxygen. And if you look at the ionization energy of sulfur comparing with oxygen, the ionization energy is very low, which means it's easier for sulfur to lose electron, and oxygen, it's very difficult to lose first electron. And look at the second value. In second, ionization energy of oxygen is much higher than second one of sulfur. So there must be dipole in case of SO2. So you write tick here. Number 2, add 150 degrees centigrade and 103 kilopascal. All of the compounds listed in table 1.2 are gases. Under these conditions, 0.284 gram of one of the compounds occupies a volume of 127 centimeter cube. Use this information to calculate the MR of the compound, hence identify the compound from those given in table 1.2. Show your working. Now we know that PV is equal to nRT. You can use this equation. PV is equal to nRT. Now from the question, what data we have? Temperature is provided, which is 150 degrees centigrade. So it will be converted to Kelvin. So you write 150 plus 273 and you will get 423 Kelvin. What about pressure? Pressure 103 kilopascal. So we need in Pascal. So I will multiply it by 1000. So I'll get 103,000 Pascal. Volume V 127 centimeter cube. It must be in meter cube. So I will divide it by 1000. So 127 multiplied by 10 raised to the power -6. That will become meter cube. Mass is also provided. 0.284 gram. Now to find MR, we also know that number of moles is equal to mass by MR or AR. Here MR is written, so we will consider MR. So putting the value of N in the equation, that is N, number of moles. What we will get? We will get PV is equal to mass by MR multiplied by RT, or MR is equal to PV MR is equal to mass into RT by PV. Now placing the values, first of all, you need the value of R. Look at this value of R here. It's 8.31 joule per Kelvin per mole. So MR is equal to mass 0.284 multiplied by R 8.31, temperature 423 divided by pressure 103,000, volume 127 into 10 raised to the power -6. We will get 76.3. 76.3 is the MR. Now I want to identify the compound. So what I will do, I will write the formula of the compounds. If you look at the compounds here, we have CO2, SO2, CS2, and SCO. So we have CO2, SO2, CS2, SCN. Let's write there MR. For CO2, MR, it's 44. SO2, MR is 64. For CS2, MR is 76. What about SCN? It's 58. So it must be CS2. So you write CS2 here. Moving to next part. The group 2 elements Mg to Ba are all silvery white reactive metals. A1, draw a table diagram to show the bonding and structure of group 2 metals at room temperature. So the marking key suggests you have to show 2 rows with a minimum of 4 particles. Particles means cations, metal cations. But I always suggest my students that's better to show at least 3 rows of cations. So the cations must be like this. 1, 2, 3, 4. 1, 2, 3. Second row. Third row. 1, 2, 3, 4. Putting positive inside. So we have this option. You can place positive inside, or they are saying it's a cation of group 2. So if you want, you can even write X2 plus. So instead of showing plus, what we will do? X plus 2, like this. X plus 2, X plus 2, X plus 2, X plus 2. What else is left? Now all this is surrounded by little circles labeled electrons, either like this, electrons. You can show this in small circles like this. This will be the final diagram. Okay, number 2, explain why Mg has a higher electrical conductivity than Na. Now they are asking us to compare the electronegativity of Mg than Na. Look at the position of Mg and Na. Here's Mg, here's Na. Na in group 1, Mg in group 2, which means it has higher number of delocalized electrons. So you can write Mg can contain more delocalized electrons than Na. B, write an equation for the reaction of magnesium with cold water. Magnesium is a metal. Whenever these metals, they are among the top reactive metals, not highly reactive, but is one of the highly reactive, but not highly reactive. So it will definitely form hydroxide and hydrogen gas. So you'll get MgOH whole twice. That's magnesium hydroxide plus hydrogen gas, H2. Let's balance the equation. So I will place 2 here. Now it's balanced. C, identify a single reagent that can be used to distinguish separate samples of dilute MgNO3 whole twice aqueous and dilute BNO3 whole twice aqueous. Explain your answer. So you can take any soluble sulfate or hydroxide. any soluble sulfate or sulfuric acid or soluble hydroxide. So like soluble sulfate, you can take K2SO4, K2SO4 or H2SO4 or soluble hydroxide like NaOH. So barium will form insoluble precipitate, BaSO4. BaSO4 is insoluble precipitate, and with sodium hydroxide it will form barium hydroxide, BaOH whole twice is insoluble precipitate. So what about magnesium? Magnesium forms soluble one for magnesium sulfate or magnesium hydroxide. Okay, moving to next question. D1, describe what is observed when SRI2 aqueous reacts with concentrated sulfuric acid. Now, SRI2 is strontium iodide. When it's reacted with concentrated sulfuric acid, there will be number of products. Like we will be getting sulfur, we will be getting iodine, we will be getting hydrogen iodide, we will be getting H2S gas, hydrogen sulfide, and get some insoluble precipitates also. So for sulfur, what you will write, it must be produced as yellow solid. So you'll write yellow solid here, yellow solid. For iodine, what you will get? You will get purple gas or gray solid. What about hydrogen iodide? Gives a misty fume. So I will write misty fumes. What about hydrogen sulfide? Produce gives a rotten egg smell. So you write rotten egg smell. And you will also get white precipitate. Compound X and anhydrous group 2 bromide is dissolved in water and titrated against aqueous silver nitrate. A solution containing 0.250 gram of X requires 33.65 centimeter cube of 0.05 mole per dm cube AgNO3 aqueous for complete reaction. Identify X. Show your working. So first of all, we need to calculate the moles of AgNO3. Moles of AgNO3 from the data provided. So according to this data, 1000 centimeter cube of solution, 1000 centimeter cube contains 0.05 moles. Therefore, 33.65 centimeter cube contains X moles. Do the cross, what you'll get? You'll get X is equal to 0.05 multiplied by 33.65 divided by 1000. So the number of moles for AgNO3 must be 0.05 multiplied by 33.65 divided by 0.0016825 or 1.6 825 into 10 raised to power minus 3 moles. Now they are saying group 2 bromide. So group 2 bromide must be reacting with 2 moles of AgNO3. So if I write group 2 bromide must be XBr2, XBr2 reacting with AgNO3. So here we have 1 mole reacts 2 mole, Y moles, let's have Y moles of X Br2 reacts with 1.6825 into 10 to the power minus 3 moles. Do the cross, so we'll get Y is equal to 1.6825 into 10 to the power minus 3 divided by 2. So it must be 8.4125 into 10 to the power minus 4 moles of Y. Now we know that Mr is equal to mass by moles. So we have the mass, we have the moles. So what you will do? We'll divide the mass, that is 0.25 by the moles, which is 8.4125 into 10 to the power minus 4. 0.25 divided by 84125, it is 297.17. 297.176. So it's reacted with, the compound is with Br, so which is XBr2. Straight away subtract the masses of Br. So 297.176 minus, it will be 2Br. So where is Br? Here is Br. It's 79.9. So 2 multiplied by 79.9, what we will get? 79.9 multiplied by 2, 159.8. Minus 159.8, 137.376. Here's group 2. It must be barium, 137.3. So it must be barium. That's all for this video. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.